Imagine you spend weeks writing an original 3,000-word essay. You do the research, draft the arguments, and right before submission, you ask an AI like Claude to fix a few stray commas and format your tables. You hit submit, and an automated audit tool instantly rejects your work. The scanner flags the entire document as 100% AI-generated. Hours of your actual human intellectual effort are mathematically erased. Anthropic intentionally embedded this mark. It is a calculated part of the model's design, a digital fingerprint woven deep into the language of the output itself. We built these tracking systems to identify synthetic disinformation and automated spam, but because of how the underlying mathematics operate, the exact technology designed to secure digital truth is now systematically penalizing human writers. To understand why this is happening, we have to look at August 2nd, 2026. That is the exact day Article 50 of the European Union's AI Act became legally enforceable. The law laid down a strict transparency mandate. Any company providing a generative AI system had to clearly mark synthetic outputs or face penalties of up to 15 million euros. Facing massive financial liabilities, Anthropic, the company behind Claude, made a calculated choice. Instead of dealing with the operational latency of running separate servers just for Europe, they applied this new invisible watermark across every single commercial endpoint globally. This triggered the Brussels effect, where a localized regulatory mandate in Europe effectively set the technical standard, locking over global networks for users everywhere else. One transparency law across the Atlantic forced a worldwide architectural shift in global software infrastructure. Complying with this law requires two completely different strategies. Securing visual media, like PNGs and JPEGs, is the easy part. For images, AI developers use a standard called C2PA. It embeds a hidden cryptographic manifest directly into the file's metadata, logging exactly when and how the image was generated. It acts as a brittle seal. If someone crops the image or alters a single pixel after generation, that cryptographic signature instantly breaks, providing immediate proof that the file was tampered with. Securing visual files is structurally straightforward because image formats possess built-in architectural space where you can hide verification data. Plain text, however, has absolutely no hidden metadata channels. If you try to slip extra zero-width characters into a document, basic code sanitizers and text parsers will instantly strip them out. Anthropic's solution was to insert the watermark directly into the probability distribution of the generated words, right at the model's inference layer. During generation, the AI evaluates the entire dictionary of possible next words. Using a secret cryptographic key, it divides that vocabulary into two pseudo-random subsets, a green list and a red list. The system then applies a mathematical nudge, a token sampling bias. This mathematically forces the AI to heavily favor selecting its next word exclusively from the green list. That selected green list word loops right back into the context stream to help decide the next word, creating an unbroken chain of mathematically biased choices. To a human reading the final output, the prose looks completely natural. It maintains perfect grammatical fluency. But over a large enough sample size, this statistical overrepresentation of green list words becomes obvious to an auditing algorithm. The vocabulary choices themselves form an undeniable machine-readable fingerprint. There is a massive structural flaw here, and Anthropic openly acknowledges it in their technical documentation. A detected watermark only proves that the AI processed the text. It does not prove the AI authored it. This creates severe risks for enterprise CTOs. If a human software engineer writes an original application, but uses an AI coding assistant to debug it, that proprietary code is suddenly injected with synthetic ownership flags in private repositories. In academia, universities are abandoning post-generation AI scanners altogether. The tools trigger rampant false positives against students who write their own papers but use AI purely for structural outlining. Corporate and academic policies often attempt to ban entirely AI-generated text while permitting AI-assisted editing. Because the mathematical watermark blindly triggers on both, enforcing that kind of binary policy is impossible. The software engineering community quickly retaliated. Open-source developers began circulating evasion tools specifically dedicated to neutralizing these text watermarks. It turns out the mathematical signal is highly fragile. Passing the watermarked text through a semantic rewriter or applying heavy human edits shatters the exact token sequence, breaking the chain of detection. You don't even need specialized software. Simply translating the watermarked text into another language and then immediately translating it back into English completely resets the probability distributions and wipes the fingerprint clean. To navigate this, organizations are realizing they must pivot away from post-generation scanners entirely. True compliance requires strict internal API logging and version-tracked writing environments to prove human oversight. Relying on mathematical tricks to ensure long-term content provenance is ultimately a flawed strategy. The invisible fingerprint effectively tracks algorithmic processing across global networks, but it fails completely as a measure of true human authorship.